Welcome back to the deep dive. Okay, so you send over some really comprehensive material on React. It looks like a great guide covering fundamentals right up to pretty advanced stuff, almost like interview prep.
Yeah, it's quite thorough. Covers a lot of ground.
So our mission today is to navigate this. We're focusing on React, obviously the fastest growing JavaScript, library, right? Not framework.
That's a crucial distinction. Yes, library.
We want to pull out the core concepts, really get under the hood with things like the virtual DOM, and understand the impact of React hooks. Basically get a solid grasp on modern React development.
Sounds good. And starting with that library point is key. React, originally from Facebook, Jordan Walk, back in 2011, it was built specifically for user interfaces, SPAs mainly.
Right. Single-page applications. And that focus is its strength, isn't it? The component model, for instance, allowing reusable UI pieces.
Absolutely. That and server-side rendering support, which was, a big deal for SEO back then compared to some other options.
People also talk about the gentle learning curve compared to something like Angular.
They do, though there's a flip side. Because it is just a library, you often end up pulling in other tools for things like routing. A full framework handles that.
And the JSX thing, writing HTML and JavaScript, that can feel a little bit weird at first.
It can. Inline templating, JSX. It does sometimes lead to more complex-looking code, especially for newcomers.
Okay, let's dig into that core thing, the VDOM, the virtual DOM. This seems to be the magic behind React's performance. Before React, changing a small thing could mean, what? Rebuilding the whole page structure.
Pretty much, or at least large parts of it. Manipulating the actual browser DOM directly is slow. Really slow. It involves the browser's rendering engine, layout calculations, repainting. It's expensive.
So the VDOM avoids that. How?
Well, the VDOM is essentially an in-memory copy, a JavaScript object representing the real DOM. Think of it like a blueprint.
A blueprint.
Updating this JavaScript object, this blueprint, is incredibly fast compared to messing with the actual DOM elements.
But wait, if you change something, doesn't React still have to figure out what changed by comparing the old blueprint to the new one?
Huh?
Doesn't that comparison take time too?
Yes, but that's the clever part. React actually keeps two of these blueprints in memory.
Two, okay.
One for the current state and one reflecting the state before the update. When something changes, React runs a diffing algorithm. It compares the two VDOMs very efficiently.
Diffing, like finding the differences.
Exactly. It pinpoints the minimal set of changes needed, just the specific elements that were actually added, removed, or modified.
And then it updates the real DOM.
Only then. It takes that minimal patch list and applies only those specific changes to the real slow DOM. It avoids unnecessary work.
So it turns a potentially huge update into a small surgical one. That's the speed boost.
That's the core idea, yes. Efficient updating by minimizing direct DOM manipulation.
Makes sense. Okay, foundation laid. Let's talk about actually building components. JSX comes first.
Right, JSX, JavaScript XML. It looks like HTML, but it's really just syntactic sugar.
Sugar for what?
For React.create element calls. Under the hood, your JSX gets compiled down to these function calls. But writing it directly makes defining the UI structure much, much simpler, way easier to read and write.
Okay. And then as soon as you have a list of things like mapping an array to components, React yells at you about keys. Why are keys so important?
Keys are crucial for React's diffing algorithm when dealing with lists. They give each item in a list a stable, unique identity among its siblings.
Siblings, right. Not globally unique.
Correct, just unique within that specific list. When the list changes, items added, removed, reordered, React uses the key to track which element is which.
And without keys?
Without keys, React might have to guess or might end up destroying and recreating DOM elements unnecessarily. This kills performance and can lead to weird bugs, especially with input fields losing focus or state.
Got it. Keys for stable identity in lists. Now, the big concepts, props versus state, often confusing for beginners.
Definitely. Let's break it down. Props, short for properties, are how components talk to each other. Specifically, how parent components pass data down to child components.
Passed down, and the child component can't change them.
Exactly. Props are immutable from the child's perspective. Read only. If the data needs to change, the parent has to pass down new props.
Okay. Immutable input. So what's state?
State is data that a component owns and manages internally. It's private to that component.
And it can change.
Yes, state is mutable. But crucially, you don't change it directly. You use a special function like setState in class components or the setter from useState in functional ones.
And changing state. That's what causes the component to re-render, right? To update the
Ah.
UI based on the new data.
Precisely. Modifying state is the primary trigger for a component to reevaluate and potentially update the DOM via the VDOM diffing process we talked about.
Okay, props down, immutable. State internal, mutable, triggers re-renders. That leads us to component types. Class versus functional. Historically, classes were the main way.
For a long time, yes. Class components use ES6 classes. They have a render method, lifecycle methods like component didMount, and you access props and state using this, like this.props.name or this.state.count.
And state updates use this.setState.
Correct. Which could sometimes be a bit tricky, dealing with this binding and the asynchronous nature of setState.
Functional components were simpler, initially just functions taking props. But they couldn't hold state, right?
They're dumb. Exactly. They were primarily for presentation. If you needed state or lifecycle logic, you had to use a class.
Until React 16.8, that seems like a huge turning point.
Massive. The introduction of hooks basically leveled the playing field. Functional components can now do everything class components could, often more cleanly.
We'll get to hooks in a sec, but first, one more basic block, handling forms, controlled versus uncontrolled components.
Right. This is about who manages the data in form inputs, like input or text area.
So controlled components.
In a controlled component, the React component state is the single source of truth for the input's value. You set the input's value prop from state, and you use an onChange handler to call your state setter function every time the input changes.
So React is always in control of the input's value.
Completely. Every keystroke updates the state, which then updates the input value. This gives you fine-grained control, validation on the fly, etc.
And uncontrolled.
Uncontrolled is more like traditional HTML. The DOM itself handles the input state. You don't set the value prop from React state.
So how do you get the value when you need it, like on form submission?
You use a ref. It's a way to get a direct reference to the DOM node and pull the value out when needed. It's simpler for basic forms, maybe, but you lose that immediate React control.
Okay, makes sense. Now, the revolution, hooks. React 16.8. You said they leveled the playing field for functional components. How?
Well, hooks are basically special functions that let you hook into React features like state and lifecycle methods directly from functional components. No need for classes anymore.
So they solved the state problem for functional components.
Primarily, yes. The most fundamental hook is useState. You call it inside your functional component to declare a piece of state.
How does it work? What does it give you?
It returns an array, a tuple, actually, with two things. The current value of that state variable and a function to update that value.
Like comps count, set count, useDate 0.
Exactly that pattern. Count holds the current value starting at 0, and you call setCount whenever you want to change it, which triggers a re-render. Super clean.
Okay, so useState handles state. What about things that aren't directly part of rendering, like fetching data or setting timers, subscriptions, side effects?
That's where useEffect comes in. It's the hook for handling side effects in functional components. It replaces lifecycle methods like component didMount, component didUpdate, and component will unmount.
How does it work? You pass it a function.
You pass it a function, yeah. That function contains your side effect code, like an API call. React runs this function after the component renders to the screen.
Does it run after every single render? That seems inefficient.
Ah, good point. It can, but you control that with the second argument to useEffect, the dependency array.
The dependency array. Right.
If you provide an array of variables, the effect will only rerun if one of those variables has changed since the last render. If you pass an empty array, it runs only once after the initial render, like component didMount.
And if you don't pass an array at all?
Then it runs after every render. Sometimes needed, but often leads to performance issues or infinite loops if you're not careful.
And useEffect handles cleanup too, like canceling subscriptions.
Yes. If the function you pass to useEffect returns another function, React treats that as the cleanup function. It runs this cleanup function before the component unmounts and also before the effect runs again on subsequent renders. Prevents memory leaks.
Okay, hooks seem powerful, but the sources really stress these two rules about using them. What are they?
They are absolutely critical. Rule 1, only call hooks at the top level of your React function. Don't call them inside loops, conditions, or nested functions.
Why not?
Because React relies on the order in which hooks are called to associate state and effects with the right component render after render. Changing the order breaks things.
Okay, top level only. Rule 2.
Only call hooks from React function components or from your own custom hooks. You can't just call useState inside a regular JavaScript utility function or a class component method.
Got it. Discipline is key. You mentioned custom hooks. What are those for?
Custom hooks are the solution for reusing stateful logic between components. Before hooks, you might use patterns like higher order components, HOCs, or render props.
Right, which could lead to wrapper hell. Lots of nested components.
Exactly. Custom hooks let you extract component logic, including calls to other hooks like useState and useEffect, into a reusable function. Conventionally, their names start with use.
So like use fetch data or use window size?
Precisely. You can then use that custom hook in any functional component, just like a built-in hook, making your components cleaner and logic reusable without deep nesting.
And overall, did moving from classes to hooks help with performance?
Generally, yes. Functional components with hooks tend to be lighter. There's this binding overhead, no class instance creation. Bundle sizes can be smaller, and component trees are often less nested, which means less work for React's reconciliation process.
Okay, we've covered the VDOM for speed, hooks for structure. Let's talk about scaling, managing bigger applications. Component lifecycle comes up.
Right. Even with hooks abstracting some of it, understanding the phases is useful. There's initialization, setting up state props, mounting component added to DOM, updating, re-rendering due to state prop changes, and unmounting, removed from DOM.
And methods like component did mount in classes map to these.
Yes, component did mount ran after mounting, component will unmount ran before unmounting. UseEffect covers these use cases now.
A big part of scaling is optimizing performance, specifically stopping unnecessary re-renders. How do we handle that?
Well, in classes, you could use should-component-update to manually check props and state and return false to skip a re-render, or use React Pure Component, which does a shallow comparison for you.
Risky to do manually, though.
Very. Easy to get wrong and introduce bugs. In functional components, the main tools are React.memo, which is like pure component for functional components, and the useMemo and useCallback hooks.
What do useMemo and useCallback do?
UseMemo caches the result of an expensive calculation, so it's not recomputed on every render unless its dependencies change. UseCallback caches the function instance itself, which is useful when passing callbacks down to optimized child components, preventing them from re-rendering just because the parent function got recreated.
Got it. Caching for stability. Speaking of stability, error boundaries seem critical.
Absolutely essential in production apps. They are special class components. This is one area where classes are still needed that catch JavaScript errors anywhere in their child component tree during rendering or lifecycle methods.
So if one small component crashes,
It doesn't take down the entire application. The error boundary catches the error and can render a fallback UI instead, like, oops, something went wrong here, instead of a blank white screen.
much better user experience.
Way better.
What about strict mode? It doesn't run in production, right?
Correct. React Strict Mode is a development-only tool. You wrap parts of your app in it, and React performs extra checks during rendering.
We'll call it checks.
It helps find components with unsafe lifecycle methods, warns about legacy API usage, detects unexpected side effects. Basically, it helps you write more resilient, future-proof code. It highlights potential problems early.
Okay, now, a common growing pain, prop drilling. Sounds annoying.
It is annoying. It's when you have to pass props down through multiple layers of components that don't actually need the props themselves.
Just passing them along.
Just passing them along, maybe 4 or 5 levels deep, only so a deeply nested child can finally use the data. It makes intermediate components unnecessarily complex and harder to refactor. Context API or state management libraries like Redux are often the solution here.
Right, and for navigation in these larger apps, React Router is the standard.
Pretty much the de facto standard, yeah. It handles client-side routing, keeping your UI in sync with the browser URL without full-page reloads, essential for that SPA feel.
The source mentioned a neat trick using the router for passing data between sibling components. How does that work?
Yeah, it's clever. Since siblings don't have a direct parent-child link, you can use the router. One sibling uses history.push not just to navigate, but to encode some state into the URL path or query parameters.
And the other sibling reads it.
The other sibling component, when rendered due to the route change, can then read that data back from the URL parameters using tools provided by React Router, like the match.params object. It uses the URL as a temporary communication channel.
Interesting workaround. Okay, last big question. The hooks versus Redux debate. Can hooks completely replace Redux for state management?
The million-dollar question. For a local component state, even complex state, hooks like useState and especially useReducer are fantastic. useReducer in particular gives you Redux-like patterns within a component.
But for global state, across the whole app,
For large, complex applications with a significant amount of shared global state, The general consensus is usually no. Redux or similar libraries like Zustan, Jotai still provides benefits like a centralized store, predictable state updates, powerful middleware, and excellent debugging tools like the Redux dev tools that are hard to replicate easily with just vanilla hooks and context API for truly large-scale state.
So they often coexist. Hooks for local, Redux for global.
Exactly. That's a very common and effective pattern in many large React codebases today. Use the right tool for the job.
Okay, so we've traced the journey. The VDOM solving the performance puzzle, hooks bringing elegance and simplifying component logic, and then tools like error boundaries, memoization, and state management for scaling reliably. It feels like a much clearer picture of modern React.
It's a powerful ecosystem, and it's still evolving. While hooks cover almost everything classes did, there are still a couple of niche lifecycle methods, specifically get snapshot before update and the error boundary methods get derived state from error and component did catch, that don't have direct hook equivalents yet.
Ah, interesting. So even the hooks revolution isn't quite 100% complete in replacing every single class feature.
Not quite yet. It covers the vast majority of use cases, but those few edge cases remain. It just shows the library is always refining, always building.
A good reminder that learning never stops. Keep exploring, keep building, and see how these concepts play out in your own projects. Thanks for joining us on this deep